Hi. So, this is the the last video I'm gonna make that's not edited, and that is very low budget, because what in the world? Why would you even do that? But mainly because I feel like I'm going through these too fast. Just recording and then uploading and then submitting and then just being a complete nothing burger. Like, that is not acceptable. But to explain, you know, intense SAT studying and learning all the concepts of the reading and writing and math modules, yada yada yada. That kind of took up my time, and I kind of put all of this off until last minute. So um, hi. But that's not what we're here to talk about today. We're here to talk about today about how to find the zeros of a function, and as well as their multiplicities. I hope I said that right. I hope. But anyways, anyways, so this is the problem we've been afforded to us, and as you can see, we're in Canva right now, mainly because I couldn't put this on my usual software, so we're gonna use Canva now. And I really like Canva, so this is fine. Everything is fine. But anyways, we are being asked how to identify all the zeros of the function below, this function right here that I perfectly plastered onto the screen, and their multiplicities. Multiplicities, right. So, there are a couple of things we need to know. Firstly, when it comes to finding the zero. Um, so, to explain what a zero is, and hopefully to explain it in the best way possible, a zero is where this line, this or either line, whichever line that you have, crosses the x-axis, and we already know that the x-axis is going to be this one, and the y-axis is going to be this line up here. Okay, just for all of the people that don't happen to know this already, I don't know how you made it through geometry, but anyways, totally not throwing shade, but it's where the line crosses the y-axis. And you could kind of think like it's called zero because there's the value of x. There's a value of x as a polynomial. We need to find the value of x as a polynomial that equals zero, right? So I think that makes sense. I hope that makes sense. So now, with that being said, we can kind of just pick out the points, that cross the x-axis. Easy peasy, right? I know. Honestly, I think this is a little too easy, and I don't know if I'm being tricked right now, just explaining this. Like, if there was something else that I didn't read over here, and it's asking me to grab this and do a whole bunch of other stuff because Mr. Goff and Mrs. Better never make anything easy, so this is like kind of nerve-wracking. um Totally, it's a little nerve-wracking, but we're gonna go with it, and we're gonna say they gave us a break on this one. um Hopefully. But anyways, we're going to pick out the points where it crosses the x-axis. So that is going to be -2, this one, because it crosses it. And then also, I should probably explain, this 3 is also going to be in here. Even though it doesn't cross it, we are still looking for things that touch. And that's kind of what it means. We're talking about making the polynomial equals 0. Because, as you know, this all of this is going to be 0 for our y. And we want that like that. So, yeah, I think that explains it good enough. But moving on. So we have our 3 points. Let me just map these out. We have -2, comma 0. We have 1, comma 0, and we have 3, comma 0. So now that we know that, now we can start setting this up. So let me just do this real quick. X minus 2, because, we have to have our x. Sorry. X plus 1. And then, these are really big, but x plus 3. And we want to figure out which term gets it to equal 0. I almost thought that was a 0 right here. Let me just make this more noticeable. There we go. To equal 0. So there we go. And obviously, if you know something about, algebra 1, then basically what you want to do is you want to subtract all of these numbers from both sides, or adding depending on which one you have, plus or minus. Add 2, and clear this out actually. And then moving on, once you do all of that, I do need to get rid of this first base, and you'd get x equals 2, positive 2, x equals negative 1, negative, and x equals negative 3. Right. So, there. Those are all your zeros. So, that's pretty straightforward, I think. It shouldn't need any more explaining. But next we need to talk about multiplicities. Oh my gosh, I said it right. Okay, so multiplicities are kind of like, no, they tell how many times a vector contributes to a 0. And they also are technically what helps label the degree. And something important to note. It's just that when it comes to these shapes, you may think, oh, well, since we have 3 zeros, then obviously we have 3 multiplicities, because, 3 is just a great number. No, that's not how that works. There is something more significant to how these lines are actually shaped and how they cross the x-axis. So speaking of which, I guess I'll just draw this out. So we have this shape. We have this interesting looking flat shape that's not actually very flat, thanks to me. We have this U shape, and then we have a straight line. So there's a rule that we have for this. Wow, I know. And basically, when you have a U shape that bumps the x-axis, that would technically mean you have a I'm not writing all of that out. We'll just do, oh gosh, we'll just do this. But you'll have a multiplicity of 2. Even though it looks like it's touching it only one time, there are 2 different marks in here. Okay, we have a multiplicity of 2. Now moving on to this one. I know I'm moving very out of order, but it's okay. When your line that you have right here specifically crosses the x-axis and it doesn't do any twists or turns or anything like that of the sort, you're gonna be working with a multiplicity of 1, because it's just like, one straight line. Okay, we have to make things simple. So, of 1. There we go. And then working with this right here, when you have one of these curvy bendy thingy-mabobs that I like to call them, that, graze the line or the x-axis, what I meant to say, a little bit, and then it goes, down, or if it comes up, depending on which way you go, you're going to be working with a multiplicity of 3, okay? That is important to remember. Of 3. 3, 2, and 1. And these numbers will also help you find the degree. There we go. The degree. Very hard to read, but and the degree being, basically the highest exponent thingy mabob being raised. And then to find like the turnout of that, you'd have to minus 1. But we're not doing all of that, okay? We're only doing what this has. So, yeah. Anyways, um it still feels a little easy, okay? But anyways, so we have one of these curvy bendy thingy mabobs. So we know we have 3 right now. And then we also have one of these U shapes, and this looks like a steeper one. So we obviously know that we're going to be working with a number that's like greater than 1, like by a lot. So that'll be 2. So right now we're at 5. And then we have this one line, or this one part of the line that goes straight down. So we know we have another 1. And then if you add all of these together, you will get a 6. Okay? Degree of 6. And yeah, that's basically how it works. Um and um you know, yeah. So um math is still Candy Crush, and that's how it's done. So, mhm.